Hi, my name's Dan, and this video is one in a short series of videos talking about and developing registers, which is within the larger context of a whole load of videos about creating a simulated CPU from fundamentals of the logic gates all the way through to a working 4-bit CPU. So there's a roadmap of where we're going for that down in the description below. The content of this video will rely on understanding the content of previous videos. So if you're dipping in, that's at your own risk in that sense. I'm using DigitalWorks software for simulation, which is free to use. There's also in the description below a link to where you can get hold of that. So we're doing registers, and we've done some discussion as to the problems to do with reading and writing to buses for registers. Registers are small memory components that form part of the CPU. And in this video, we're going to finally get to actually make something again, and we're going to make a 1-bit register, which can then be multiplied up to make larger registers. So the basic component we're going to use for this is a D flip-flop, which is the data flip-flop, which is able to store data. If you don't understand what one of these is, then you've got other videos to look at and to work out. And we're going to have it's going to need to deal with a bus, so we're going to have a bus input. And I'm actually going to just do a line as if it were a bus. I'm going to stick an LED in here, even though it's part of a macro. If we're debugging, we've got problems, it might be useful to have that. So typically I create buses as a line and then tap off them, because that's how buses effectively work. And in the last video, we discussed the fact that in order to take our output to the bus, we need to use a tri-state buffer, which is a special component which disconnects most of the time and only connects when you use the enable line that's underneath. So we're going to have the enable in here, and we're going to feed that out to the bus. And you might think that we want to feed the input from the bus directly, but actually what we're going to do is we're going to add some more functionality to this, as well as the bus access. And in fact, when registers are used inside CPUs, their usage, or what they're used for, is predetermined, and they're wired specifically to potentially to different components and in different ways. So as well as bus access, it would be really useful for us, for our register, to be able to do independent data reading and showing of the value, or being able to use the value which is not via the bus. So I'm going to do the value output first of all, so that's pretty straightforward. So that just taps into the queue here, and this doesn't need to be. In fact, it's best if it's not after the tri-state buffer; it's before it. So this is not a bus ready output. This is an output that can be hardwired to something. And I'm going to start putting annotations in. So use 10 points and not bold, and I'm going to call this value. So that's an output which tells you the value that's being held inside this 1-bit register. And more annotations. This is output enable for the bus. Output enable. And this is actually our bus connection over here. So as well as being able to read from the bus, we're also going to give it a direct data input that it can read from. So I'm just going to stick that there and call that data. And it's going to be fairly straightforward to show which one that we read from. Actually, reading from separate sources is just a matter of enabling one using an AND gate. And in fact, let's stick the AND gates that we're going to need in here. So one's going to be for the bus and one's going to be for the data. I've just put an extra one in by accident. So let's wire up data to there and bus there. And we're going to, in order to choose which we're going to use, we're going to have a couple of tags here. I'm actually going to, whilst I'm at it, put two more tags in here because I know there are two more inputs that I'm going to want. And so let's wire one of those up to that, and that one up to that. And we're going to call this one this one. So this is the one that does the data, takes the input from the data. So it's data read, and the other one's going to be bus read. Okay, and these haven't been fully wired up yet. And what are these other two that I'm going to want? Well, actually, it's useful to also have the ability to set and clear the value that's inside the flip flop. So specify that it's a one or specify that it's a zero. So I'm just going to label those as well. Set and clear. Okay. So we want the data that comes into the D pin for the flip flop can come from four different places potentially, which are this this gate here, which is from the data input, this gate here, which is from the bus input. We want it from the set and potentially from the clear, but actually from the clear, we're always going to want it to be a zero coming in, so we don't actually need to wire that up as long as none of the others is active. The clear should work. So said in any of these, so the relevant gate is a NOR gate. We're going to make it a 3-input NOR gate and wire that up to there. And that one to there. And this one to set. Then the final element you might have noticed is that I haven't done anything on the enable yet. And so I could have a separate enable input, but actually what we're going to want to do is when we put a high value coming in at data read, we want that to actually read from the data. So we're going to make that is going to do an enable. In fact, each of these is going to do an enable. Same for the bus read, same for the set, and same for the clear. And the clear, when it happens, again, hopefully nothing else is coming in. So it will make it go down to zero and be clear. So we've got four possible things that are going to trigger the enable. So again, we want an OR gate, and it wants to be a 4-input OR gate this time. 4 inputs, and connect that through to enable. And connect these up. Oh, come on. I hope you enjoy watching me doing the wiring. I hope you're doing the wiring yourself, actually, and making one of these, because actually going through the process of creating this stuff is quite satisfying. And is that it? We've got quite a lot of pins here, not pins, tags. We've got a bus input, we've got a data input, we've got a value output, we've got an output enable input. So these are the kind of control elements: output enable, data read, bus read, set and clear, and that's probably enough. So let's go to our template editor. Now, why can't I go to the template editor? And I think I've got a problem with this. For some reason, I'm inside a macro here. I'm not quite sure how that happened. I think that must be something that I did before I started with this video. So I'm just going to copy all that and close macro. Yes, I've got a one-bit register sitting in there that I created previously. And then I'm just going to paste that. So I'm now at the root level. So that was my error. Hopefully you didn't make that error. And we're going to save this as a reg 1-bit. And so, as always, we're going to test it. So let's make a new circuit. I've sounded very confident when I've been putting this together, as if I know exactly what I'm doing. Oh, look, of course I don't know what I'm doing, because I have not done the template, which is the thing that I was going to do. And I forgot about it immediately. So, ooh, reopen. No, I don't want one of those. It's just open. Circuit has changed. Don't save the circuit now. And I want for Reg 1. There we go. Right. Template editor. This is where we should have been going. And we've got a small box which we're going to make bigger. And I guess the placement of stuff here is starting to become important, potentially. So let's think what we're going to have. What we're going to have. Let's still keep it so that inputs are at the top. So we've got a bus input and a data input. We're going to have an output at the bottom. In fact, I am going to move those around. That's going to be the value output. I'm going to move that bus so that it's... I'm going to separate the idea of bus access from standard access, actually. So I'm going to put the bus there. I'm going to put bus read and output enable all on that side. I'm going to put, that's going to be the value. That's going to be the data and data read, and I'm also going to put at the top set and clear. Let's have an overall thing, which is a 1-bit register. And then let's start labeling inputs. And I'm just going to double check numbers. So I've got 1, 2, 3, 4, 5, 6, 7, 8 tags. I've got 1, 2, 3, 4, 5, 6, 7 pins. So what am I missing? I was going to do bus, bus read, output enable. That's going to be value. I've got data. I want data read set and clear. So data read. I'm just going to move this a little bit further along. Excuse me. Will that do? Move that quite a bit further that way. Right, let's have some annotations. I've got a feeling that I just want to make this a bit bigger, because mostly because the text in the middle is going to start encroaching on my labeling. I will move that back further over a little bit. So bus read and output enable, which Normally, because that's quite long words. Normally is written as OE for output enable. Um, and I'm going to label the top ones, so data, um, and we're just going to call that read, set, and clear. Um, read, set, clear. I'm just going to do them all in one annotation because it's lined up quite nicely. And then the final one down here is going to be value. So one thing that I've done that's a bit defensive is, as in, will help me not make mistakes, is that I have done clear labeling in both my circuit and my macro, so I should be able to make those connections together, uh, hopefully without making an error. So there's only 8 of these to do, so I'm not going to fast forwards and play you some music. You're going to have to bear with me. Data, I could sing to you or hum to you, but I'm not sure the world is ready for that. Um, so I'll kind of waffle on a little bit as I do this, which is that it may seem a bit over kill to have so many different controls for a simple 1-bit register. Um, that's the bus read. But actually, this makes the register quite versatile. As I've said in a previous video, one of the um, uh, characteristics of registers in a CPU is that they're wired differently depending um, on their purpose, and so making it so that different kinds of wiring are possible makes them really useful. It means I can reuse the same bit of circuitry. Um, which brings me to a general principle of how I'm doing this, which is that I am trying to make things that can be reusable, and so we're not making specific registers for specific uses. When CPUs are actually created, um, part of the design process would be to actually eliminate uh, eliminate gates that you don't need and make everything as specific as possible to make it as small and as fast as possible. And the compromises that I'm taking are partly in terms of uh, uh, being trying to make it so that it's easier to understand what's going on in the process, partly for the sake of the amount of time for yourself and for myself that it will take to create this stuff. Um, Um, and yeah, so I was going to say, and partly to keep things simple, but that's the same as the first thing that I said, which is that understanding is easier when you stick to principles as much as possible and don't cloud things with lots of specifics for lots of different things. We've got enough of that going on already. Anyway, so um, hopefully that's that done. So we can now save. It's already got the name range one bit, and then we're going to do new circuit. We're going to want to test it. Uh, so as I'm testing things that have bus access, I will always be wanting to create some kind of bus to show that, and elements that can independently read and write from the bus. Well, actually, reading the bus is not a problem because what I tend to do is I tend to put LEDs on the bus so that it's easy to see what value the bus is holding at any point in time. Let's try that up. But I'm gonna, I only need one because we've only got a one bit of bus going on here, but I'm gonna add element here which is going to be able to independently set a value on the bus so that we can, and this is needed for testing. Um, and it would have been possible to create a specific macro just for doing this bit, but actually you tend not to have the inputs and the outputs on the macro, and you just end up wiring as much together as you would in this circumstance. Right, so we need several inputs. We're going to have 4 across the top here for data, read, set, clear. We're going to stick an LED on the value so that we can keep an eye on what's actually being held in the register. And then we're going to wire up the bus access stuff. Right, so the bus access goes directly to the bus that we're using. And then we just want a couple of inputs for bus read and output enable. So I can tell what's going on there. Right. Let's simulate. Okay. So our value immediately has become 1. And if you watched the previous videos that I did about the bistables and the simple memory circuits, then you'll remember that that was a feature of the simulation, that it always seems to settle as 1 in the way that I put it together. Is not necessarily reliable. Yours might go the other way. It might depend on the order that you put the gates into the simulation, for example. Anyway, so we're gonna first of all test the setting on the clear. So set goes to 1. It's already 1. Clear makes it go to 0. Set makes it go to 1. Pressing set again doesn't make it change. Pressing clear makes it go off. Pressing clear again doesn't make it change. Let's put data in here and see if we can test a data read. So data read, yes, and if we put the data to 0 and do a data read, that reads to 0. If we want to read from the bus, we don't actually know what the value is on the bus, so we're going to use this in terms of being able to read to the bus. So let's enable this. And now, so the bus has got 0 or the bus has got 1. Let's try it with the bus at 1 first, and let's do bus read. And bus read should store it. Here we go. And let's make it 0 again. And let's do bus read. So good, that's tested that. Let's put 1 back in using the bus read. And let's disable that so that we can now enable our own output. Output enable. And that tells the bus, in fact, we're going to leave that output enable switched on, tells the bus that the value is the same as is in the register. And if we do a clear on this now, it clears it both in the register and it'll clear the value that's being used at the bus. Set makes it high. So I think that's all the functionality that I wanted to test. We've got quite a lot of control input on this 1-bit register. And in order to make this useful for a 4-bit CPU, of course, we're going to want to create a 4-bit register. So that's going to be the next video, but that's it from me for now.